Hi, welcome to the Demo Forum Executive Interview Series. Today I am joined by Christopher Kruegel, who is the VP of Security Services at VMware, and by Shawn, who's the CTO of End User Computing at VMware. Welcome, gentlemen.
Thank you, Richard. Glad to be here.
Thanks for having me, Richard.
Christopher, let's start with you and talk about workload protection and cloud and network security. Christopher, VMware is pretty much a vast company, but it's got a lot of security capabilities. Tell us about those areas that you're responsible for, especially if it touches on zero trust.
Perfect. Yeah, I think you're right. We have a very broad product portfolio, and in general, I think we're not necessarily known as the security company, and we're more known, of course, for IT infrastructure. And I think that is really something that has significantly changed over the last few years, both with acquisitions that we have made as well as organic development. So we're super excited to offer a lot of security capabilities. Zero trust is, of course, an important trend in the industry, and one that we have to incorporate into our messages and products as well. The way we view zero trust is it's not just one little feature or one little security policy. It's a fairly broad and encompassing concept, and as such, I think it requires a broad set of capabilities and, of course, a broad product portfolio so that you're able to pervasively instrument, monitor an infrastructure and be able to make access control decisions and detections. And, in sort of the broad scheme, we're dividing the capabilities within VMware with related to zero trust into those that are more focused on the end user, so the securing the users and their endpoints. And then on the second part, we are trying to secure the workloads, the networks, and sort of your cloud properties. And I'm in the networking and security business unit, so I'm more responsible for that second part. So securing workloads and applications and the things in your data center and the network and sort of the whole multi-cloud environment.
It makes sense since VMware is responsible for the infrastructure for all those workloads.
Exactly. So especially when you look at the private clouds and data centers, VMware has a fantastic footprint. I think pretty much every large organization in the world runs some type of VMware vSphere products. And so the idea here is why not build security capabilities? Why not build monitoring, policy enforcement, and threat detection capabilities into that fabric? And that's exactly what we have done with NSX and the NSX distributed firewall. And I'm happy to talk more about our more recent capabilities there. But I think it's also important to note that that's not all, right? It's important, of course, to protect that virtualized environments, but you don't want to stop there, right? Security teams don't say, hey, I'll just protect my VMware environment and that's it, right? They want to have broader visibility. They want to have visibility in all their cloud properties and data centers. And so we have built a number of capabilities to expand our view into these areas as well. And of course, happy to talk more about this too.
Okay, well, let's first focus on that workload protection because I'm so old school. I just need the same stuff I had when I had a server. And a VM is smaller container, and a container is an even smaller container. So I need some sort of integrity management and some sort of onboard, anti-malware solution, vulnerability management, and then a endpoint firewall. Is that what we're talking about here?
Yes, and I think it's a very good observation that you say, okay, so of course you think of these sort of traditional security tools, but one important question is, how do you actually make all these capabilities, for example, malware detection or policy enforcement, or maybe even vulnerability analysis, how do you make that work for every workload, especially if you look at the network, right? We are used to having maybe a perimeter firewall. And so what happens to all that east-west traffic? What happens to lateral movement when the attackers are inside your network? And so, people have started to say, well, maybe I can tap network traffic, inside my network at some core switches. And obviously that's actually, very, very complicated. It's a costly proposition. You have to maybe change the network infrastructure. And even if you do that, I would question that you would be able to see all the connections. And even if you see all the network connections, there's the problem of VM to VM or container to container traffic that might happen on the same physical host, right? Because it actually never touches the physical network. So what you would want is this very broad and also deep visibility that really is able to see everything. That's how it starts, right? You have to see a certain connection. You have to see traffic to be able to defend threats against threats that might be in these connections. And so this is where it starts, and where it really helps that we can put our firewall, our monitoring into the hypervisor, right? Into the hypervisor of each of those physical hosts. That means we see now all the traffic that happens between any machine and even any VM. So that's the first part. So you see things. And then the question is, so what are the capabilities that we offer, right? And here are two, I think, big classes. One is segmentation or microsegmentation. You're able to enforce policies, and you're able to enforce policies also based on the knowledge of, okay, what workload is running, what protocols are these workloads speaking, what are the users that are logged in. So there's a lot of information that we have because we're sitting in the hypervisor that allows us to enforce those policies. But we also say that's not enough, right? Because just because you have a policy that limits what the attacker can do, but you have to allow some connections in order for everything to work. And now the question is, what happens if the attackers piggyback on top of these connections? They're basically embedding their threats in these connections. And so what we need to do is threat detection. We need to inspect the traffic. We need to look for signs of known badness with an IDS, IPS. We need to look for behavior-based outliers, anomalies, signs of threats using our NDR, network detection response solution. And we also have an anti-malware solution that is leveraging a whole pipeline, including a sandbox, to grab files that are in motion, or once they have hit the VM, directly from the VM, because our hypervisor can peek into the VM. So we have sort of network-based threat detection capabilities, as you would imagine, that include IDS, NDR, and network sandboxing. And then as a final point, we also have the ability to look at the workloads themselves using an endpoint agent, Carbon Black workload protection, where we can then get things such as vulnerability information. We can determine, of course, if there is some malware, a host-based exploit happening on the endpoint on that workload. And the cool thing is we can put all of this together and we can help each other out, right? We can use endpoint context, like, is this a vulnerable service, to make our intrusion detection system better, because it can then look for specific threats against specific applications and determine if they're vulnerable. Or our network can bring information back to the endpoint and make the endpoint solution better, because it knows now how maybe the big picture looks like in a network. So it's very beneficial to have both views and have the capability to interact with each other to give you a more complete protection.
Got it. Thank you so much, Christopher. I'm sure everybody's going to want to see the demos that you're providing.
Thank you. Thanks for having me.
Okay, Shawn, let's talk about end-user computing protection and zero trust. Help us understand what you mean by end-user computing at VMware.
Yeah, so we consider end user computing, all things that end users in an organization would interact with. And that means the devices they use, whether it's a mobile device or a fixed function, laptop, desktop type device, all the resources that user accesses, whether it's mobile applications, whether it's desktop applications, web applications, SaaS applications. And part of that, of course, is obviously the identity that is used to authorize and authenticate the users to those resources. And it's also, where those resources sit. Some of those resources might be in the private cloud in the data center. Some of them might be in the public cloud. And we need to be able to do attestation and security for any type of application resource accessed by those users. So that in a nutshell is what end user computing is all about.
Got it. Now I understand why we're talking about zero trust at VMware.
Yeah, so zero trust for us, really, it starts with kind of the user at the center. And it is very heavily influenced by identity, because identity is really the main control point where you'd want to exhibit some zero trust related controls. But it goes beyond identity as well, because there are a lot of places that you can implement controls for zero trust. Certainly, identity and access control is one of those areas where you can use as an enforcement point to say, hey, this user is not authorized to access this application. But there are also ways that we can do enforcement at the endpoint. Let's say if a device compliance falls out of corporate standards, we can, remove access to applications on the device. We could maybe remove access to their remote access or VPN technology they're using. Or in some cases, we can just go remediate the problem. So if the end user device, they disable the firewall as an example, that would be a violation of our policy. Rather than saying, oh, you can't access these applications anymore, let's just go remediate that problem and turn the firewall back on and enable the user to continue seamlessly accessing their applications. And we also have some inline security capabilities as well. For example, if a user is accessing a data center centric application, we have a zero trust network access tunnel that we call Workspace ONE tunnel. And we use that in a couple of different ways. We can use it as a replacement for a traditional network-based, full device tunnel, if that's what a company chooses to use. What we prefer to do, though, is for companies to start moving to a per application VPN approach, where we capture the traffic on the edge, destined to a specific resource in the data center, and we create a tunnel or a microsegment of one between the user's device and the data center centric resource. By doing that, we reduce the amount of network access that end user has. So even if the edge device is compromised by an attacker, and let's say they have a remote access Trojan on the device and they can see the screen and keyboard the user is doing, and they try to launch a network-based attack into the data center, because we've done that microsegmentation and restricting what that user can access, they have very limited access into the internal network based on the policy controls that we've employed. And the exciting thing is that those protections don't only extend to the data center. We've taken that same Workspace ONE tunnel technology, we've containerized it, and we've deployed it in the VMware SASE POP. So SASE, or Secure Access Services Edge, is a technology that we've developed that takes the capabilities that we had in our software-defined WAN technology stack, and we've integrated this Workspace ONE tunnel technology into the SASE POPs, so we can terminate a user's access not only in the data center, but out at the edge near all the public clouds, so they get very low latency transmission to the edge networks. And then we can do inline security. So things like web filtering and sandboxing and all those types of things can be done out at the edge, close to the cloud applications the user is using. And that gives us an inline network enforcement that we can employ with that tunnel technology as the user transits through the network out to their application resource.
Wow. So zero trust application access, which is the most granular form of zero trust, and SASE on top of that.
Yes.
Do the two work together? Is it the same agent?
Yeah, it's exactly the same tunnel technology that works for Workspace ONE for any data center centric applications we're going to access the user to. That same tunnel application is used for accessing the SASE POPs, for accessing any web or SaaS applications. So same technology in both places. And we've also integrated it tightly with our multi-factor authentication inside Workspace ONE. So we can control at a very granular level which applications we invoke multi-factor. And when we go to invoke multi-factor, in addition to doing it on a per application basis, we can use the influence for whether or not we do a challenge response for multi-factor based on things like device compliance. So if the device has something risky on it, we can invoke multi-factor, but only invoke multi-factor for specific applications. So if the end user is accessing the cafeteria menu, we don't really care that much about the cafeteria menu. Let it happen even if there is a slight risk of compromise on the device. But if they're accessing a critical business application or finance application, then we could do some step-up authentication to make sure the user proves that they are who they say they are, both from an identity and from a device attestation point of view. And we also do risk analytics on top of all of that. So we've developed some machine learning models to look at device behavior, to look at user identity and access behavior, to look at things like how many times is this user logged in successfully or unsuccessfully? Where are they logging in from? And we've developed ML models to take all those things into account. So even if the user's device looks healthy, if something they're doing from an identity access point of view looks abnormal, we can, of course, do multi-factor challenge response, but we can actually do additional things like quarantine that user in the network and restrict their access, or prompt them to do certain things to prove an attestation that they are, in fact, the user that's making this request.